attention and that we get through this as quickly as we possibly can. We're going to be focusing today on multiplying and dividing with powers involved. So we have what's called a product of powers and a quotient of powers rule. Okay, so if we take a look at something like the following, if we have 2 to the 4th and we want to multiply it by 2 to the 5th, if I were to go ahead and write this out longhand, okay, so if I start with the 2 to the 4th, if I expanded this out, that would be 2 times 2 times 2 times 2, and then again I'm multiplying it by 2 to the 5th power. So if I expanded 2 to the 5th power out, that would come out to 2 times 2 times 2 times 2 times 2. So now if I wanted to simplify this to where it was just a single base and a single power, what would my base be? 2, and then the exponent would be a 9, right? 2 to the 9th power. Okay, same thing if you're talking about, remember I told you we're going to be involving variables now as well. So if we had x squared times x to the 4th power, x squared times x to the 4th power, it's the same idea. If we were to go ahead and expand it, that would be x times x, and then we're going to multiply it by the expanded form of x to the 4th power, which is x times x times x times x, and then that would give us our base being x, and what would our exponent be? 6, right? So, seems simple enough. Okay, hey, I just expand it and then recalculate to find out what my exponent is going to be. But what if you come across a situation where it's something like, 3 to the 24th times 3 to the 18th? Do you really want to write that all in expanded form? No. I don't want to write 3 24 times and then another 18 times. That's just too much for me to do. So there's a simpler method to it. What do you think is actually happening when we multiply 2 of the same exact bases together? What are we actually going to be doing with the exponent? Can anybody make a connection here? So look at the original problem. 2 to the 4th times 2 to the 5th, and then what the answer became, 2 to the 9th. What did we wind up doing? Adding the exponents. That's all we actually did. So in a problem like here, because of the fact that they have identical bases, they both have a base of 3, then I'm going to keep that base, I'm going to keep the 3, and I'm going to take the 2 exponents, that 24 and that 18, and I'm going to add them together, 24 plus 18. And then that will give me 3 to the 42nd power. Again, I don't want to sit there and write out all of those 3's when I can just simply follow a rule that states that I need to go ahead and keep the base, add the exponents. So let's write that down. That's called the product of powers. The product of powers rule. So if you come across a situation when you are multiplying, if you are multiplying powers, of identical bases, and it's important, the bases have to be identical. The bases have to be the same. If you're multiplying powers that have identical bases, then you keep the base. You have to keep the base and add the exponents. That's all you're doing. you're going to keep the base and then add the exponents together. So I'm going to give you 2 problems to try on your own. We have x to the 3rd times x to the 7th. And then I have y to the 4th times y. Try those 2 on your own. All right, let's go ahead and go over it. X to the 3rd times x to the 7th, Aaliyah? X to the 10th, very good. Again, you're going to keep the base, because the bases are the same, right? So it's going to stay in x. Then you're going to take your exponents, and you're just going to add them together. So you're just doing 3 plus 7, and that's going to give you x to the 10th power. Okay, what about for problem number 2, Alonzo?
Y to the 5th power?
Y to the 5th power. Even though this is y, remember back in our invisibility math board, at the very top, we said that every single value, every number, has an exponent. If the exponent isn't written, it's automatically a what?
1.
A 1. If the exponent isn't written, it's automatically a 1. So whenever you see a problem that doesn't have an exponent written, get into the habit of putting a 1 there. So that way you know it exists. Okay? So again, the bases are the same. So we keep the base. And then we're just going to add the exponent. So 4 plus 1. And that's going to give us y to the 5th power. Y to the 5th. Okay? Now, sometimes you're going to come across a situation in which you have multiple bases and multiple exponents. You would still follow the same rule. So if I give you a problem like -7 x squared times 11 x to the 5th. So here in this situation, I have more than one base, right? -7 is a base. X is also a base. 11 is also a base. However, do I have any like bases with -7? No. Do I have any like bases with x? Yes. Do I have any like bases with 11? No. But do I know how to take -7 and multiply it by 11? Do we know how to do that? Yeah. So from this point on, you will need to simplify your expressions as far as you can, your powers as far as you can, which means you should no longer have multiple numbers. You should simplify those numbers as much as you can by doing the operations it tells you to do. So what I'm going to do is I'm going to take that -7, I can actually multiply it by 11. I can do -7 times 11. And what will that give us? -77. Good. Then I'm going to focus on x squared and x to the 5th. X squared and x to the 5th I can do because when I multiply x squared times x to the 5th, I'm going to keep the exponent or the base and I'm going to add those exponents together. So when I work that problem out, it's just going to become x to the 7th power. Okay, so my final answer, and I'll write it down here so it's neater, is -77 x to the 7th. And then I'm done. So those numbers need to be simplified as far as you possibly can. We're not going to leave numbers in exponential form anymore. We're actually going to work them out and evaluate as much as we possibly can. Let's try another example. We have 2 mw to the 4th, and we're multiplying this by 8 m to the 5th W to the 6th. Okay, so again, we've got a lot of things that are going on here. We have a lot of stuff that's going on here. We've got numbers. We've got bases with M. And we've got bases of W. So that means we're going to split this up into 3 problems. 3 separate components, and then we can combine those components together at the end. So the first thing you always want to do is work in with your numbers first, and then you're going to work alphabetically. So when you're working your problems out and you're giving your final answer, the most appropriate way to give your final answers is to have your number first, and then you go down the alphabet. So you go in alphabetical order when you're relaying your variables. Is that okay? You guys understand? Okay. So we're going to start off with the 2s and the 8s. Can I zoom in? Does everybody have this stuff written down? Okay, so let me zoom in so you guys can see it a little easier. Okay, so we're going to start off first by doing 2 times 8, because I've got a 2 here and an 8 here. So I'm going to focus on doing 2 times 8. And what is 2 times 8 going to give me? 16. Okay, then I'm going to move on to my first letter of the alphabet from this problem. Which one is first, M or W? M. Okay, so we're going to focus on M. So I have M to what power? The first. And then I have another M to the 5th power. So M to the first times M to the 5th, I'm just going to add those exponents together. And that's going to give me M to the 6th power. Okay? Then I move to the next letter that I have. I have W to the 4th and W to the 6th. So W to the 4th times W to the 6th, I'm going to keep my W and I'm going to add my exponents. So I get W to the 10th. Okay, so each of those is a separate little problem. I'm just now going to piece it all together. 16, M to the 6th, W to the 10th, and that's my final answer. How do you guys feel? Yeah? Okay? You ready to try a few on your own? All right. Let's write it to the next page. We're going to go to page 65. All right, try those 3 problems. Alright, let's go ahead and go over this. So for problem number 5, I'm going to call on, we'll go with Con. Con, what did you get for problem number 5?
Well, with
X to the 12th power. X to the 12th power. So you're going to take the base. The base is all the same, right? They all have a base of x. And you're just going to add the exponents. So 9 plus 2 plus the 1. And that's going to come out to x to the 12th power. X to the 12th. Okay? For problem number 6, we're going to go ahead and go with Devin. But you didn't raise your hand to say you need more time. Huh? Oh. How, Aiden? Okay, so it's not 30. What's 2 times 3 times 7? 42. So it should be 42 x to the 4th, y to the 7th. Okay, so let's piece them all together. Like I said before, you're going to focus on the numbers. You can actually go ahead and multiply those numbers together. So we can do 2 times 3 times 7, and that's going to give us 42. Okay, then we're going to look at the x's. The x's is the next one that's in alphabetical order. So we have x to the 3rd, and we have an x, which would be x to the 1st. I'm going to go ahead and write a little 1 up there. So that would be x to the 3 plus 1 power, right? X to the 3rd and x to the 1st. We would add those exponents together. That would give us x to the 4th. Okay, and then we would focus on the y's. We have y to the 5th and y to the 2nd. So y to the 5th times y to the 2nd would simplify out to y to the 7th, because you would add those exponents. So if you piece it all together, you get 42 x to the 4th, y to the 7th power. 42 x to the 4th, y to the 7th power. All right, let's take a look at problem number 7. Kelly, what did you get? Yes, but remember, we want to do alphabetical order, so x comes before y. But yes, that is correct. So we're going to take our values, our coefficient values, -8, 2, and 5, and we're going to multiply those together. So we're going to do -8 times 2 times 5. -8 times 2 is -16. -16 times 5 is going to give you that -80. Okay, then we're going to take the w's. Remember, we're going in alphabetical order, so we have a w to the 3rd, we have a w, which is technically to the 1st, and we have a w to the 2nd. So we do w to the 3rd times w to the 1st times w to the 2nd, and we're going to add those exponents together. That's going to give us w to the 6th power. Okay, then I have some y's and I have an x, but again, I want to go in alphabetical order, so I'm going to go with the x first. So we have an x, but there's nothing to combine with the x. It's just x to the 1st, so it would stay x. And then the last one, the last part would be the y's. Y to the 4th times y. Y to the 4th times y, that's really y to the 1st. You would add those exponents, and that would come out to y to the 5th. Okay, and if you piece it all together, it's just -80, w to the 6th, x, y to the 5th. Raise your hand if you need another practice problem like that. And it's okay if you need one. Everybody's comfortable with the multiplication portion. All right, then we're going to move on to the division portion then. Unless you would like to stop here and just have homework on multiplication only. Then that's what we'll do instead. Okay, so actually, if I give it to you now, we can check it, and if you get it done before class, we can check it, and then you don't have to have homework. That sound good?
Yeah.
All right, so here's what we're going to do then, is go ahead and flip to the other page. We're going to flip to page 66, and we'll put the assignment on here, and then we'll go over it at the end of class. That means you have to be done. You get 20 minutes to work on it, because I need 10 minutes to be able to go over the answers. 20 minutes only. So start working on it now. Now remember, so we're going to simplify each expression. Oops. Now remember, if you have a problem and you leave your answer as 2 to the 4th, x to the 2nd, if you leave it like that, it's going to get marked wrong. You would have to actually simplify it. You cannot leave it as 2 to the 4th. You have to actually work 2 to the 4th out. You would have to actually work 2 to the 4th out. You would have to put 16 x to the 2nd. That would be the correct thing. So from now on, unless it's otherwise stated, if it says, hey, leave it all in exponential form, then you would leave it in exponential form. But if it says to simplify, you simplify those numbers as much as you can. So if you have a number with an exponent, you evaluate that, okay? Can I move past number 1 and number 2? Yes? So that way you guys can see the other on the bottom.